back everybody, I am a teacher from ILN Online Academy. In today's video, the topic is preparation of the salts. This is basically chapter number 12 of the ongoing series for the Cambridge Chemistry 0620, and in today's video we'll be having a look at this chapter, which is preparation of the salts. So further ado, let's just begin. First of all, you should know about the salt. The contents which we will discuss in today's video will be the importance of the salts, and second, the preparation of the salts, in which we have soluble salts and also the insoluble salts. So first start with the salt. First, you should know about salt. The simplest definition of a salt will be the ionic compound that are made by the neutralization of an acid with a base or an alkali to form the salt. We have read about in the previous chapter of 11 in which we read about the acids and the bases. We have the reactions of the acids with the different substances like metal, reaction of a metal with the acid, reaction of a acid with the base or alkali, and also the reaction of a acid with the metal and the carbonate. So the reaction of an acid with the base or an alkali is a neutralization reaction. In that reaction we have two products. When acid react with the base or alkali, this one is the journal equation for that reaction, and we have the products which are salt plus water is released. So this is how the salt is prepared by the reaction of an acid and a base, and this reaction is known as neutralization reaction because we have two substances in our reactants which have a different pH, and when they are combined with each other they neutralize them and form a neutral substance, which is the salt and the water. Water, as we already know, that has the pH, pure water has a pH of 7, which is the neutral pH. So salts are made by the ionic compounds, and you already know about the ionic compounds. These are formed between the metal and a non-metal and by the complete transfer of electrons. So there is a one atom that is present in the salt as metal, and the other one is the non-metal. So there is a wide range of different types of salts, and many of them also play an important role in our everyday life. Many important minerals are the single salts and some are double. Like in the example of this one, the most important or the common example of the salt is the sodium chloride salt that we use in our daily life, and it is essential for the life. It is important raw material for the industries, and it has so many different functions, like it is also used in the muscle contraction. Sodium is a metal and chlorine is a non-metal. So this is an ionic compound that is formed between the metal and a non-metal, and the name will be, we have generally the two parts of the salts. You can see here the first part comes from the metal oxide or the metal carbonate that is used in the reaction, and the second part comes from the acid. Second part, this chloride, comes from the acid. Like we have the base gives the metal oxide or the metal hydroxide, and the non-metallic part or the second part of the salt comes from the acid. And the name of salt can be determined by looking at the reactants. Like for example, in the formation of the sodium chloride we have hydrochloric acid, that is the parent acid that always produces the salts that end in the chlorides and contain chloride. Other examples, we have sodium hydroxide, NaOH, sodium hydroxide, when reacts with the hydrochloric acid it forms the sodium chloride. And zinc oxide, when reacts with sulfuric acid, zinc oxide, that is the base that reacts with the sulfuric acid, and when these react together they form a salt which is known as zinc sulfate. So the first part comes from the base and the second part of the salt comes from the acid which we are using. So the parent acid for the formation of the zinc sulfate is sulfuric acid, and the base is zinc oxide. So this is how you can name a salt and what is a salt. The method that used depends upon the solubility of the salt being prepared. There are different uses of salts like fertilizers, batteries, in cleaning products, in healthcare products, and also salts are important branch of the chemistry, and it has important uses of this class of compounds. So we have this one, salt. Next, if we talk about the salts, like for example, if we replace the hydrogen in hydrochloric acid, this is the acid and base react together to form the salt. So if we replace the hydrogen in the hydrochloride with the potassium atom, then what will happen? If potassium is replaced with hydrogen, then we have potassium chloride. Then the salt potassium chloride is formed, which is the KCl. So this is how you can prepare a salt. Mostly hydrogen, as acids are the proton donors, so hydrogen can be replaced from the acids to make the for the formation of the salts. Now we'll talk about the sodium chloride, which is also known as the common salt. Sodium chloride is mined from the underground deposits of the rock salts. In many parts of the world, salts can be found where the salt lakes dry up through the evaporation, and in some other cases, the sea forms and crystals of the sea salt are also formed. Sea salt is not just the sodium chloride, it also contains magnesium chloride, we have calcium sulfate, and we have also potassium bromide, KBr, and some other salts are also included. Sodium chloride is essential for the life, and it is also used, or it is also involved in the muscle contraction. Sodium chloride is also involved in the muscle contraction, like it enables the conduction of the nerve impulses in the nervous system, and it also regulates the osmosis, and it is converted into the hydrochloric acid that aids in the digestion in the stomach. So when we sweat, we lose both water and also the sodium chloride. Electrolytes are also lost. So the loss of too much salt during the sport and exercise can give us muscle cramps. So for that purpose, we have the isotonic drinks are available in the market, and you can get that isotonic drinks, and they are designed to replace this loss of water and also to restore the energy and the balance of the mineral salts in our body. So this is all about the introduction of the salts, which is an ionic compound. Next, we'll talk about the soluble salt and the insoluble salts. There are so many salts that are obtained by the mining, and others must be made by the industry. So therefore, we have some methods that are available to make the salts, and some of them can be investigated in the laboratory. So for the solubility of the salts, two things are more important in working out the method for the preparation. First, you should know about whether a salt is soluble or not, whether it is soluble or insoluble. And second thing you should know about whether the crystals of the salt contain water, chemically combined or not. So the first point influences the preparation method that we choose, and the second point affects how the crystals are handled at the end of the experiments. So we have the soluble salts and the insoluble salts. So now I will tell you about the rules for the solubility of the salts. The first rule for the solubility of salts is that sodium, potassium, and ammonium salts are soluble. All sodium, potassium, and ammonium salts are soluble. So you should remember all these rules for the soluble salts and also for the insoluble salts. All the nitrates are soluble. Next, chlorides are soluble except lead and silver. The salt which is made by the lead and the silver with the chloride are insoluble. Other than that, all the chloride salts are soluble, like sodium chloride salt is a soluble, but lead chloride and silver chloride is a insoluble salt. Next, sulfates are soluble. All the salts that are prepared by the sulfate that are soluble, like we have read about the zinc sulfate. So zinc sulfate is a soluble salt. And except, there is a just acceptance also in the salts made by the barium, calcium and lead with the sulfate are insoluble. Other than that, all are soluble, like zinc sulfate is a soluble, but barium sulfate, calcium sulfate and lead sulfate is a are the insoluble salt. Next, carbonates are insoluble. Carbonates form the insoluble salt except sodium, potassium and ammonium carbonate. They form the soluble salts, like calcium carbonate is the insoluble salt, and in case of sodium carbonate, potassium carbonate and ammonium carbonate, all these three salts are the soluble in case of the carbonates. So all the other carbonates are the insoluble. Next, we have hydroxides, the salts made by the hydroxides, oxides and also the metals also. So hydroxides are insoluble. There is also acceptance in this. So hydroxides are insoluble salts, or they form the insoluble salts, except we have sodium hydroxide, that is the soluble, potassium hydroxide, ammonium hydroxide, all these are the soluble one. And if in case of calcium hydroxide, like slaked lime, that is partially soluble and partially insoluble. So these are the solubility rules for the salts. So you have to remember all these to check whether a salt is soluble or the insoluble salt. So next we have, you should know about now the hydrated substance or the anhydrous substance. Hydrated is a word that refers to water. So hydrated substance is a substance that is chemically combined with the water. We have some substances that are hydrated, means they are chemically combined with water. Water is not physically attached to them. There is a chemical reaction that happen, and then water is present as a part of their structure. Next we have anhydrous. You can see here the prefix "an" before this one, that means absence. So anhydrous means the substance that is containing or no water, contains no water in it. So that is the anhydrous substance. Next we have water of crystallization. If water is chemically combined in the hydrated crystals of some salts, that is known as the water of crystallization, and this water of crystallization is represented in the formula of the hydrated salts, like we have cobalt chloride dot 6H2O. So this is the water of crystallization, and how we can write represent in the formula of the hydrated salts. So this water gives the crystals their shape. In some cases it also gives them their color. For example, we have copper sulfate crystals. In case of copper sulfate, it will be Cu. In case of copper sulfate crystals, these colored crystals are those of the transition metals. So the crystals of hydrated copper sulfate are blue. They contain water of crystallization in their structure, and their blue color is due to the water that is present in their structure. They are blue crystals, copper sulfate. So we have cobalt chloride crystals. They are pink. And so some crystals have their color just because of some have their color that is because of the water of crystallization that is present in them. So when these hydrated salts are heated, their water of crystallization is driven off as the steam, and the crystals lose their shape and become a powder. Like copper sulfate crystals, as we have read here, they are blue. When they are heated, what happened to them, we will see. Like when these are heated, what will happen to them? They become now anhydrous, which we have read here. The word hydrated and the anhydrous. Hydrated means water is present, and anhydrous means no water is present, or water is not contained in their structure. So when copper sulfate crystals are heated, they become a powder, they lose their shape, and copper sulfate crystals are blue when they contain the water, but when we heat them, they now become the anhydrous CuSO4 plus water is released, or water is driven off as the steam. So when they are heated, they are dehydrated to form a powder, and they lose their shape, and that powder is of color in white. So you can easily check by their color change if the water is present in them or not. Crystals that lost their water of crystallization are said to be anhydrous now. If water is added back to the white hydrous copper sulfate powder, the powder turns blue again and heat is given out. So this can be used as a test for the presence of the water, and blue anhydrous cobalt chloride can also be used for this test. The change in color with the blue cobalt chloride is pink, and when we heat them, now we have the anhydrous cobalt chloride that is in blue in color. So cobalt chloride, when water is present there, now it is pink, and when it is anhydrous, it becomes the blue. So this is about the water of crystallization. This is the term, that is the water molecules that are present in the hydrated crystal, including their water. So this indicates that dot 5 H2O indicates 6 water molecules are attached or bound to the copper sulfate, 5 molecules in case of copper sulfate, and 6 water molecules in case of cobalt chloride. So this indicates how many water molecules are attached or bound to the cobalt chloride and also to the copper sulfate. So this is the example of the water of crystallization. And to remove the water of crystallization from a compound, you can heat it gently, causing the water molecules to evaporate and leaving the anhydrous compound behind. So now we'll move towards the second content of today's video, that is about the preparation of the salts. So first we will do the preparing the soluble salts. So for the preparation of the soluble salts, these are the salts that are soluble in the liquids, and they are made from their parent acid by using any of the 3 characteristic reactions of the acids that we have read in our previous video of chapter number 11. In the chapter number 11, we have explained the reactions of the acid with the metal carbonate, and also the third one with the base or the alkali. So you can prepare the salts or the soluble salts from these 3 reactions of the acids that we have read in the previous video. So you can check the explanation of that in our previous video of chapter number 11, that is about the acids and the bases. So for choosing the method of preparation of the salt, you can start from this one. Now I will show you here the flow sheet diagram through which you can easily assess which you are going towards. First of all, we will start from here. You have to start, and first you should check, does the metal react with the acids? Does the metal react with the acid or not? So the first question that arises, does the metal react with the acids? If yes, then you have to move forward and check, does it react safely? If yes, then you have to move forward, and we have 2 conditions There are some metals that do not react with the acids, and some will react because of their reactivity. Some are more reactive, some are less reactive. The one who's are more reactive, they will react, and then we will check does the metal react safely or not, means if they have moderate reactivity or high reactivity. If not, then you have to check is the base or the carbonate soluble. If yes, then you have to move towards a method for the preparation of the salt. If not, then you can move another method, this one. So does the metal react safely, or if yes, then you have to move toward a specific method. If not, then you can go back towards this one. If it does not react safely, then you have to move towards the base or the carbonate to check whether it is soluble or not. So you can use three methods for the preparing of the soluble salts. Is the metal react safely, then you can choose a method A, which is the method A, and that method is you can prepare a salt by using excess metal and acid. Acid plus excess metal can react together because the metal can react safely, so followed by the filtration. You can further do the filtration for the separation of that. So you can prepare salts, for example magnesium sulfate from this method. You can prepare zinc chloride from this method. So these salts can be prepared from the method A if the metal is reactive, so you can use this one. Next method for the preparation will be, this is the method A for the base, to check whether a base or a carbonate is soluble or not. If it is not soluble, then you can prepare the salt by reacting the acid with the excess solid. Acid plus excess solid react. If it is not soluble, in case of calcium carbonate, or mostly carbonate salts are insoluble, right? So you can use a base or carbonate which is soluble. If not, then you can add the acid plus the excess solid, and you can also do the filtration also. So you can prepare copper sulfate from this process, which has also the water of crystallization like H2O. Next, if the base or the carbonate is soluble, yes, then you can use the method of titration. Titration method is used for this one, in which the acid and the base react together, and we have examples of NaCl, we have potassium sulfate. So all these are produced by the method of titration, in which the acid and base neutralize, and acid is present in more quantity, and we will add the acid drop by drop in that titration method by using a burette, and the end point will comes. In that end point, mostly the color changer indicator is added to check whether the reaction happens or not. So from all these methods, salt crystals are prepared by evaporation or by crystallization. After doing all these three methods, salt crystals are prepared by evaporation or by crystallization. We can evaporate the excess water that is present there, and then we have the crystals of the salt after drying them. So this is the flow chart. So this one is the flow chart through which you can easily assess or check the methods that or choose a method for the preparation of the salt. Now we will move towards the explanation of the first method, and then second, and then we'll move towards the third one. So the first method is the method A that we are using here, that is acid plus excess metal. Now I'll tell you the explanation of this one. So the method A, if the metal reacts safely, you can prepare it by using the excess metal with the acid. Like for example, we have magnesium. You can use excess metal by the reaction with the acid, like we have hydrochloric acid. 2 molecules of hydrochloric acid will be used, and what will happen? We have magnesium chloride will be formed in case of the reaction with the hydrochloric acid, and if sulfuric acid is used, then magnesium sulfate is released in this reaction. So this is the first example of the reaction of the acid with the excess metal. The metal that we are using here should be in the excess. Second, we have the zinc. Zinc also should be in excess, so you can use the hydrochloric acid for the zinc. 2 molecules of hydrochloric acid will be used, and then it will produce the zinc chloride. Zinc chloride is also produced by this method. So this is how you can produce the metals. After that, followed by the filtration, you can filter out the crystals, and then crystals are dried, or by the evaporation or by crystallization, then you can have the dry crystals of the salt that is being prepared by this method. So you can prepare the salts by this one. Next, we'll move towards these one by using the acid with the excess solid, and also by the titration method. So this is the second method for the preparation of the soluble salts. Acids react with the solid metal, the base, or the carbonate, insoluble base and insoluble carbonate. So first of all, you can see here on my screen for the preparation of the soluble salts, and we are here adding the acid. We have acid that is present, warm or dilute acid is present there in the beaker, and in that we have the stirring rod. Then add the insoluble metal or the base or the carbonate from the top of it. Heat acid until the warm, and then metal, base or carbonate, stirring constantly until it stops disappearing. Then the second step will be here. You can see the second step will be the filter the mixture to remove the excess base, transfer the solution to the evaporating basin. So this is the second step, filter the mixture into evaporating basin to remove the excess solid. So the third step here for the preparation will be, you have to leave the mixture, or you can say that heat the solution to evaporate water and to make the solution saturated. Check the solution is saturated by dipping a cold glass rod into the solution and seeing if the crystals form on the end. Leave them filtrate on a warm place, which is the next step, and to dry and to crystallize. Decant excess solution and allow the crystals to dry and to blot to dry with the filter paper. So this is how you can get the filters. This is how you can get the crystals. So this is the method for the preparation of the soluble salts. First, you can see here adding the metal or the base or the carbonate in the warm acid. The second step is the filtration, and the third step is the evaporation or crystallization, or last one is remove the evaporating basin from the top and allow the filtrate to dry the crystals. So these are the steps or methods through which you can prepare a soluble salt. Second is by the titration method, or reacting a reacting a dilute acid with an alkali or the soluble base. Next is the titration method, and that titration method is and the example through which we can prepare the salts from acid plus the excess metal, base or the carbonate is, we can use copper oxide, and that copper oxide will react with the sulfuric acid. We have the warm dilute sulfuric acid that is present in the beaker, and from the top you can add this copper oxide. After reaction, we have the salt, which is copper sulfate plus water is released. here with that. So this is the example for this, for the salt that is prepared through this method. So next we have titration method. In this titration method, reacting a dilute acid and an alkali or the soluble base. The first step is you add the alkali or the indicator to a conical flask. In this one is the first step, in which you are adding the alkali plus the indicator. You can add any indicator like thiamolphathene, you can add phenolphthalein, any other, which we have read in the previous chapter of the acid and the base. Alkali plus indicator is present there in the first step. Second, you have to add the acid in the burette. This one is the burette and acid should be in the burette. Acid is added drop by drop, so burette is filled with the acid. And the third step is add the acid to the alkali until the indicator change in color. You can calculate the volume of the acid added by checking the initial reading and the final reading from the burette. Here we have the measurement that is present on the burette. So drop by drop acid is getting into the base or the alkali that is present in our beaker, and what will happen after some times, the color change will happen. We have a solution that is neutralized, and we can check that by the indicator that we add in the first step. So acid plus base reacted and then they form a neutralized solution. You have to transfer this solution to an evaporating basin on which the evaporation will be done, and heat them to evaporate the water that is present in it. The next step is removing the evaporating basin from the heat and allow the filtrate to dry. So this is the method through which you can calculate the volume of the acid that is added from the final and the initial reading. And in the last we have the salt that is produced by this reaction or by this method. This method mostly involves the neutralization of the acid and the acid with the base or the soluble alkali, and you can use any indicator, methyl or thiamolphathene, which are added to the acid and the base. So this is the method of the quantitative analysis. By using the solution, one solution is slowly added to a non-volume of another solution by using a burette until the endpoint is reached. A piece of glass apparatus that is used for delivering a variable volume of the liquid accurately is the burette that we are using in this reaction or in this method of titration. And the end point, you can see here the pink one that is formed here just because of the addition of the indicator, is the point in a titration when the indicator just changes the color, showing that the reaction is complete. So there are some steps which I already told you about this titration method. So this is how you can prepare the soluble salts. The first one is by the method of the acid plus the excess metal and base or carbonate, and the second method is by the titration method. So this is how you can prepare the soluble salts by these methods. The titration method is very useful not for preparing salt but also for finding the concentration of the particular acid or also the alkali solution. So now these are the methods for the preparation of the soluble salts, and next we'll move towards the preparation of the insoluble salts. As these are the insoluble salts that are not soluble in the liquid solution but they form the precipitates, like for example this is the container in which you have a liquid, and these salts are present as a precipitate in our liquid solution. So that's why we call it as the insoluble. These insoluble salts can be prepared by using the method of precipitation. You can use the method of precipitation for the preparation of these insoluble salts. This is the sudden formation of a solid when either two solutions are mixed or a gas is bubbled into a solution. A solid salt is prepared that is insoluble in the solution when we add two solutions mostly the two solutions of the soluble salts or a gas is bubbled into the solution. So this is how you can prepare insoluble salt by using the precipitation reaction. We have the reaction between the example of this precipitation reaction is the reaction between the marble chips, which is the calcium carbonate, and the sulfuric acid, that would be expected to produce a strong reaction with large amount of carbon dioxide that is being given off. Like we have marble chips. The reaction quickly stops after a very short time. This is caused by the fact that the calcium sulfate is insoluble, and the insoluble calcium sulfate soon forms a layer on the surface of the marble chips, stopping any further reaction. Like for example, we have this marble chips. This one is a marble chip that is present there. So we have the sulfuric acid. So the reaction between the marble chips and the sulfuric acid, what will happen here? Marble chips is basically the calcium carbonate that is present there, and sulfuric acid, the reaction between them one would be expected to produce a strong reaction with a large amount of carbon dioxide. Carbon dioxide is a gas, so bubbles are released. You can see here on the surface of the marble chips, like gas is given off as the bubbles which are formed here. So hydrogen ions can't get at the calcium carbonate. Formation of a layer of the insoluble calcium sulfate stops the reaction. When the reaction between them happens, we have a layer of the calcium sulfate that is formed, like this one. Calcium sulfate is formed. When calcium sulfate is formed, then what will happen? The hydrogen ions can't get at the marble chips because now the calcium sulfate is formed. So this insoluble calcium sulfate soon forms a layer on the surface of the marble chips by stopping any further reaction. This reaction also emphasizes that some salts are insoluble in water. Like more examples are, we have silver chloride. Silver chloride is also soluble. We have read about the solubility rules also, which tells us that which salts are soluble and which are insoluble. Almost all the chloride salts are soluble except the silver chloride and the lead chloride. And also we have barium sulfate. Barium sulfate is also insoluble salt. Such salts cannot be made by the crystallization methods, by the titration methods, or by the reaction of an acid with a solid metal. So they are generally made by the ionic precipitation by this one. Like for example, we have barium sulfate that can be made by taking a solution of a soluble sulfate, sodium sulfate. We have sodium sulfate is used for the preparation of the barium sulfate. This is added to a solution of a soluble barium salt, that is barium chloride. We have barium chloride. So barium chloride is added to a solution of the sodium sulfate. This the insoluble white solid or the barium sulfate is formed immediately by the reaction between these two. We have barium will react with the sulfate and it forms barium sulfate. The insoluble solid is released, and that insoluble solid is the barium sulfate that is formed here. This is the white solid that is formed, and its precipitates are present in the solution. Is formed immediately. This solid falls to the bottom of the tube or the beaker as the precipitates. The precipitates can be filtered. It is then washed with the distilled water and then dried in the warm oven. So this is how you can prepare the insoluble salts. Like I have here, we have the diagram of the preparation of this one. In the beaker we have, this is the beaker, and in this beaker we have barium sulfate, that is the solid one that is present there as barium sulfate. This is the solid salt that is present there, and now we are adding in this we are adding the barium chloride solution. When barium chloride solution is added and sodium sulfate solution is added, then what will happen? So first of all, you have to make the solution of both the salts of the sodium sulfate and the barium sulfate, and then when these two solutions are mixed together, both of these are the soluble salts, barium chloride and the sodium sulfate. So you have to make a solution separately before adding them or before reacting with each other, because salts will not react with each other in the solid form. They will react with whether they are in the molten form or whether they are in the solution form. So when both of these solutions are added in a beaker, we have different types of ions that are present there. We have also the sodium ions, we have chloride ions, and the barium and the sulfate react together to form the barium sulfate that is present at the bottom of the tube. Why at the bottom? Because this one is the insoluble salt and the precipitates are formed. Barium and sulfate ions combine to form a precipitate of the barium sulfate. The sodium and the chloride ions stay in the solution. So the ionic equation for this reaction will be, we have barium chloride, which is the aqueous solution. We are taking the aqueous solution of the barium chloride, plus we have sodium sulfate, which is Na2SO4, and also the aqueous solution of this one, because both of these salts are the soluble. So you can prepare the insoluble salts by using two solutions of the soluble salts. When they react together, they form barium sulfate plus, which is the solid one, as this one is the insoluble, plus we have sodium chloride NaCl that is produced here, which is the aqueous form. So this equation shows the importance of stating the symbols here. You can also see the symbol which shows the state. We can tell whether this reaction equation shows a precipitation. So you can see here, this one is this salt from the precipitates. This equation can be also simplified to show only those ions that take part in the reaction and that does not take part. Like barium and sulfate took the part and the other one are not. Why? Because we have those ions which take part in the reaction changes their state. Barium and sulfate are present in the aqueous solution before the reaction, and after the reaction they are present in the solid form. So we have barium 2 positive, which is present in the aqueous before the reaction, and after we have in the solid form. So this is the ionic equation, simplified ionic equation for this reaction. We have also read about this one in the chapter number 4. We have spectator ions, like the sodium and the chloride ions are the spectators which do not take part in the chemical reaction, and they remain in the same state before and after the reaction. The ions remain in the solution are left out of the equations. The ions that do not take part in the reaction are known as the spectator ions. So this is how you can see the ions which take part in the reaction or precipitation of the barium sulfate that is prepared from barium chloride and the sodium sulfate. So next we have another example of the precipitation reaction that we mostly use. We have the different form of the equations for the precipitation of the silver nitrate, like we have silver nitrate AgNO3. That silver nitrate reacts with the sodium chloride NaCl, and it forms this AgCl, that is the solid. That means this is the insoluble, plus we have sodium nitrate that is formed here. So this precipitation reaction is often used here, and the precipitation of the silver nitrate with the sodium chloride, and it forms a silver chloride that is in the solid, and sodium nitrate that is formed here, and this one is in the aqueous form or the aqueous solution. Next, for the precipitation reactions, we have another example, like yellow lead iodide is formed by mixing lead nitrate and potassium iodide solution. Lead nitrate and potassium iodide solutions react. Lead nitrate and potassium iodide solutions react, like we have, this is the lead nitrate and we have potassium iodide solutions. Both are the solutions, so they are present in the aqueous form. When they react together, they produce a solid lead iodide. Lead iodide is released, here, and this is the solid or yellow lead iodide that is formed by mixing the lead nitrate and the potassium iodide solutions and leaving behind the soluble potassium nitrate into the solution. In the solution we have the potassium nitrate. So this can be the yellow precipitates of the lead iodide that are formed here. These are the yellow precipitates of the lead iodide, and they can be recovered by the filtration. We can filter out this solutions, and after the filtration on the filter paper you have the precipitates of the insoluble salt like lead iodide, and we have in the aqueous solution of the potassium nitrate. If the precipitate is washed, dissolved in the hot water and recrystallized, some quite spectacular crystals can be obtained, like the equation for this one will be lead ions here react with the iodide. So this one is the ionic equation for the lead iodide that is formed here, and the precipitation reaction. So the first you can see here the one which changes in the state, lead iodide that is present in the solid form, and lead ions and iodide ions are present in the reactants as in the aqueous solution. So these are the ions that take part in the chemical reaction, and the ionic equation, this is the ionic equation for this one, and this ionic equation is the simplified equation for a reaction that show the ionic substances, only those ions which actually take part in the chemical reaction that are shown here. So insoluble salts can be prepared by using a precipitation reaction, and the solid salt obtained is precipitate. Thus, in order to successfully use this method, the solid salt being formed must be soluble in the water and the reactants must be available. Now I will show you here that diagram for the procedure for which or how you can prepare a insoluble salts by using the two soluble reactants. For example, first we have to add the salts to a water and mix them, like in a separate container you have a soluble salt. This is the first soluble salt in this container, and in the second container we have a second soluble salt. You can use two solutions. You can use the solution of the two soluble salts for the preparation of the insoluble salts. After making the solution, what you have to do, you have to add both of these solutions in a separate beaker in which water is present there. So after adding into them, you have to stir it with a stirring rod. And then we have the mixture of the salt that is present there. So there is a mixture of the salts that is formed here. Next step is filter to remove the precipitates that are formed in the reaction, like after stirring it, we have some precipitates that are formed at the bottom of our container like this. So now you have to use the method of filtration for the separation of the insoluble salts from the solution. By using a funnel, you can separate out, add the mixture here on the funnel. The filter paper is present there. This is the filter funnel, and we have the filtrate that will be present there, and the filtrate is there, and the salt on the filter paper. We have the precipitates of the salt that is left behind. The third step will be wash the precipitates with the distilled water to remove the traces of any solution. After washing, dry the precipitate of the insoluble salt in an oven. You can use any oven for drying of the insoluble salt. After drying, we have the crystals of the insoluble salt that is present there. Precipitates of the insoluble salts are there, and you can use a temperature of 50 degrees 60 degrees Celsius, and this is the diagram that shows the filtration of the mixture to remove the precipitates from the solution. And the examples we have already read about that precipitation of the dry lead sulfate crystals by using our precipitation reactions, and we have the lead nitrate and also the potassium sulfate through which you can prepare it. So this one is the table through which you can easily remember which salts are soluble and which are insoluble. There is also, you can see all the chloride salts are soluble except the two, the silver chloride and the lead chloride. So through which you can easily remember the solubility of the salts, whether they are insoluble or whether they are soluble. So we will quickly revise or summarize all the topics which we have read today. The salts are the important group of the ionic compounds, and some salts are soluble in water while some are insoluble in water. There are generally solubility rules that apply to the various different type of the salts, and we have read about these solubility rules like these are the rules or the solubility rules for the salts. You can see here I told you all, and there are general solubility rules that apply to the various different type of the salts. And then we read about the hydrated substance or with the anhydrous substance. A hydrated substance is the one that is chemically combined with the water, and anhydrous means there is no water that is present there. Then we talk about the water of crystallization, that indicates the water molecules that are chemically combined in the salt crystals. And you can also use the water of crystallization for the presence or absence of water. Next we talk about the methods that are available for the preparation, separation and also the purification of the soluble salts by the reaction of the parent acid with either excess metal, second by excess insoluble base, or third with excess insoluble carbonate. Next, a soluble salt can be prepared also by the titration method of an acid with the alkali or soluble base, that is followed by the separation and the purification. We can separate out by using the filtration or crystallization. And in the last, we talk about the insoluble salts that are prepared by the precipitation reaction and then followed by the filtration. So this is how you can prepare the soluble salts and the insoluble salts. There are specific methods for the preparation of the soluble salts and insoluble salts, and through these methods you can easily reach out which salts you want to prepare. So this is all about today. I hope you understand all. If you have any question or any query, you can ask in the comment box. We'll meet in the next video. If you like the content, you can like this and subscribe the channel. We'll meet in the next one.